Alright, so the last section of chapter 6 is going to be 6.5. So what we're going to be doing is we're going to be solving the quadratic equation by factoring. Alright, remember when we factor we just break into groups to get that same type of number. Okay, so the standard form for a quadratic equation is ax squared plus bx plus c. And the way that you know that you have to solve it is because this equation is going to be set equal to 0. So to solve equations, you're going to find the number that makes the equation true. And we call these solutions, okay? And your highest exponent, which your textbook calls it the degree, is how many solutions you should have. Okay, so if I'm looking at this quadratic equation, my highest exponent is 2, so that means that I should have 2 solutions for this equation that we have up here. Sometimes you can have 3, 4, and so forth, but it's all based off of what your highest exponent is, or the degree. Okay, so if a and b are real numbers, and if ab equals 0, then a equals 0 or b equals 0. So basically what this is saying is if you multiply a times b and you get the solution of a 0, then what that means is at least one of the numbers must be 0, because 0 times any number is going to give you 0. So the Factoring is Fun worksheet, I gave this to you in the previous class. It kind of looks like this. Alright, we're just going to go over a couple things really quickly. So if I have 2 terms, if I have 3 terms, and if I have 4 terms, from that Factoring is Fun worksheet, I want us to be able to identify. So if I have only 2 terms, it could be a GCF, where we pull out a greatest common factor. It could be the difference of 2 perfect squares. Or it could be the sum or difference of 2 cubes. Okay, you're not typically going to see this in 6.5, but you will see a GCF or a difference of 2 perfect squares. Now if you have 3 terms, it could either be leading coefficient of 1, which this is where we put our a equals 1. It could be a leading coefficient where a does not equal 1. That's the one that takes a little bit of work. This is section 6.3 if you need to go back and look at it. Or it could be a perfect square trinomial. So perfect square trinomials, 3 terms, middle term is going to be even, and the first and the last term are going to be perfect squares. Now if you have 4 terms, the only option that you have is factor by grouping. Okay, and we'll practice most of these today. Okay, so zero property product. So have this Factoring is Fun worksheet out, but this is kind of a synopsis of what that worksheet looks like. Alright, now the important part is the steps. So how to use the zero factor property. What we do first is we set the equation equal to 0 by moving everything to one side. Does it matter if it's to the right or the left? Absolutely not, just to one side. Step 2, we have to factor. So this is all that we've been doing in chapter 6. Step 3, set each factor equal to 0. So when we factor it out, we're going to set that binomial or trinomial equal to 0. Step 4, we're going to solve each individual equation. So we're going to get x equals some type of number and x equals some type of number if we're just going to have 2 solutions. And then the last step, and you got to show this, is check your answer. So you must show unless you have 3 or more terms. Okay? And remember, this is all based off of whatever your highest exponent is. Okay? So let's make this real. So solve each equation. So we've got x minus 4 times 3x plus 1 equals 0. Alright, step 1, we have to make sure the equation is set equal to 0. So step 1 is done. Step 2, we have to factor it. Now, we already see that we have binomials. set equal to 0, so that means that it's already factored for us. So now what we got to do is we got to do step 3, which that means to set each factor equal to 0. So we're going to go x minus 4 equals 0, and 3x plus 1 equals 0. So we're just splitting them apart. Then step 4 tells us to solve each individual equation, so we're trying to get x by itself. So if I've got x minus 4 equals 0, what I'm going to do to both sides is I'm going to add 4. So I get x equals 4. And then right here to get x by itself, I'm going to subtract 1 on both sides. So I've got 3x equals negative 1. And then to get x by itself again, I have to divide by 3. So I get x equaling negative 1/3, which is totally fine. You can get fractions. You just got to make sure and use that calculator to help yourself out. So step 5, we have to check our answers. Since we only have 2 solutions, we got to check our answers. So we're going to let x equal 4, and we're going to let x equal negative 1/3. All right, and this is just to check our answers. So if we have those 2 solutions that equal each other, we're good to go. Let me show you what I mean. So I take my original equation, and wherever I see x, I'm going to plug in 4. So I'm going to go 4 minus 4 times 3 times 4 plus 1 equals 0. All right, and what I'm going to do is I'm going to solve from here. So 4 minus 4 is going to be 0. 3 times 4 will be 12 plus 1 equals 0. Clean up my parentheses a little bit more, so I got 12 plus 1, which is 13. So I got 0 times 13 equals 0, but we know that 0 times any number is going to be 0. Since 0 equals 0, that one checks out. I come over and I box my answer. Alright, now I'm going to let x equal negative 1/3. So first thing I got to do is wherever I see x in the original equation, I've got to plug in negative 1/3. So I've got negative 1/3 minus 4 times 3 times negative 1/3 plus 1 equals 0. Now you totally can use your calculator to be able to solve this, but I'm going to show you how to do it by hand. And the first thing that you want to do is you want to create these to be fractions, and you can do that by putting it over 1. So if we are adding or subtracting fractions, we have to have an LCD, least common denominator. So if I have 3 and I have 1, my LCD would be 3, so I need to change this to a 3, but remember what I do to the bottom I have to do to the top. So this would be a 12, because 4 times 3 gives me 12. So then I keep that denominator of 3, and I can just add or subtract my numerator. So I've got negative 1 minus 12, which would be negative 13. If you did it in your calculator and you got negative 4 and 1/3, I'm a-okay with that. Alright, now if I am multiplying fractions, the first thing that I want to look for is I want to look to see if I can cross cancel. So that's meaning from top to bottom, bottom to top. So if I cross cancel, the 3's will definitely cancel out, leaving me with 1's. Okay, and then positive 1 times negative 1 is going to leave me with negative 1 plus 1 equals 0. And we know negative 1 plus 1 is going to be 0, so I've got negative 13 over 3 times 0, and we know that 0 times any number is going to be 0, so 0 equals 0, put a check mark, and I put my box. Alright, let's look at another problem. So the next one that we have is we have y times 4y minus 5 equals 0. So the first thing I got to check for is we have to set the equation equal to 0 by moving everything else to one side. But we have 0 by itself, so step 1 is done. Step 2, we have to factor, but we can see that they've already factored it for us, and they've actually factored it by a GCF. So now we can do step 3. Step 3 says to set each factor equal to 0. So I'm going to go y equals 0, and then I'm going to go 4y minus 5 equals 0. So this one, my y is already by itself, so when I'm solving it, I don't have to do anything else. But this one right here, I've got to do some adding and division. So I'm going to add 5 on both sides. So I've got 4y equals 5. And then I've got to get y by itself, so I have to divide both sides by 4. So again, I've got a fraction. I know everybody hates fractions, but we got to make sure and practice it because you have to get comfortable with it. Okay, so that is step 4. So after step 4, step 5, since there's only 2 solutions, we have to check our work. So we're going to let y equal 0, and we're going to let y equal 5 over 4. Okay, so wherever I see y, I'm going to plug in 0 for the first one. So I'd go 0 equals 4 times 0 minus 5 equals 0. Alright, so according to Please Excuse My Dear Aunt Sally, we got to deal with this parentheses first. So I'm just going to bring that 0 down. So within my parentheses, I got to do multiplication. So 4 times 0 is going to give me 0 minus 5 equals 0. And again, I got to finish up my parentheses, so I'm going to go 0 times negative 5. But we know that 0 times any number is going to give me 0. So this one checks out. So now we've got to let y equal 5 over 4. So wherever we see y, we've got to plug in 5 over 4. So I'd go 5 over 4 times 4 times 5 over 4 minus 5 equals 0. So again, I'm going to turn this into a fraction just to make it easier to work with. You can plug it into your calculator and you will get the same result. Okay, so according to Please Excuse My Dear Aunt Sally, I've got to deal with my parentheses, so I'm just going to bring over this 5 over 4. And now I'm multiplying 2 fractions. When I multiply 2 fractions, I'm going to look to cross cancel. So from top to bottom, the 4's will cancel out. And 1 and 5, nothing cancels out. So what that means is I go 5 times 1, which would be 5 minus 5 equals 0. And we know that 5 minus 5 is going to give us 0. And 0 times any number will be 0. These two numbers are the exact same, so they equal out. So I box my answer. Okay, so that's practicing step 3, 4, and 5. But now what we got to do is we got to put in step 1 and 2 to completely work one of these problems. All right. So we're going to solve this equation. So we have x squared plus 2x plus 8. First thing we got to do is got to make sure that the equation's equal to 0. So if I look at this equation, I don't have a 0 in here. So what I have to do is I have to create that 0. So I'm going to subtract 8 on both sides. So I'm going to get 0 equals x squared plus 2x minus 8. Alright, so now what I see is I have 3 terms. So if I have 3 terms, it can either be a equals 1, a doesn't equal 1, or it could be a perfect square trinomial. So first thing that I see is this is definitely an a equals 1 because my leading coefficient is going to be 1. So I set up my 2 binomials equals to 0. I go x, x. Then I look at my signs plus minus. So I go plus minus and I find my factors of 8. So factors of 8, 1 and 8, 2 and 4, and I think that's it. Now, because my signs are different, I have to use subtraction, and I have to get to my b, which is 2. So in order to do that, to get a positive 2, I can't do 1 and 8, but I can do 2 and 4. And the order is super important, so it needs to be 4 minus 2 to get to a positive 2. So my 4 has to be positive, my 2 has to be negative. So what we just did was we did step 1, setting it equal to 0, step 2, factoring it, and now we're to step 3, so just like what we were doing before. So we're going to set each factor equal to 0. So for my first equation, I got to solve this. This is step 4. I'm going to subtract 4 on both sides, so I get x equals negative 4. Right here, I'm going to add 2 on both sides, so I get x equals a positive 2. Because I have 2 solutions, now what I have to do is I have to check them. So what I'm going to do is I'm going to let x equal negative 4, and I'm going to let x equal a positive 2. So I go negative 4 in parentheses squared in my original equation, plus 2 times negative 4 equals 8. So you always want to plug it into your original equation, so you will end up getting it correct. So negative 4 squared is going to give me a positive 16 because a negative 4 times a negative 4 will be a positive 16. Now a positive times a negative will give me a negative, and 2 times 4 gives me 8. So if I clean this up, 16 minus 8 is going to be 8 equals 8. Since those two numbers match each other, I can box my answer. Alright, now we're going to let x equal a positive 2, so I've got 2 squared plus 2 times 2 equals 8. 2 squared is 4, 2 times 2 is 4 equals 8, and then 4 plus 4 will be 8 equals 8. Those two numbers match each other. I box my answer, and this is completely how to factor using the zero factor property. Alright, now I want you to try. But before you try it, I want us to do the first step together just so we're on the same page. Okay, so I haven't taught you yet when you have a leading coefficient that is negative. So what I want you to do with this equation of t squared equals negative 3t plus 18 is I want you to move everything over to the left side so we don't have a negative t or t squared, because I would have to subtract that. So what I would want you to do is I want you to add 3t on both sides, so you have t squared plus 3t equals 18. And we have to make sure and set it equal to 0, so we have to subtract 18 on both sides. So we have t squared plus 3t minus 18 equals 0. Now, I do not care if you did this in one step. So if you added 3t and subtracted 18 on both sides to get to this solution, okay, I'm completely fine with it. Alright, so pause it for a second, and I want you to try to solve and check this problem. Alright, if you have t squared plus 3t minus 18, we know we have three terms, so it's either going to be a equals 1, a doesn't equal 1, or a perfect square trinomial. I see that it's going to be an a equals 1. So first thing I do is I set up my binomials equal to 0. I go t plus minus, so it's plus minus, and then I have to find the factors of 18. So my factors of 18 are 1 and 18, 2 and 9, and then 3 and 6. Because my signs aren't the same, I'm going to have to use subtraction to get to my b, which is a positive 3. And what I'm going to use is I'm going to use the 3 and the 6, and the order is very important. It needs to be 6 minus 3 to get to a positive 3. So I go 6, I go 3, equals 0. So I got t plus 6 equals 0, and t minus 3 equals 0. So we just set each factor equal to 0, so now what we got to do is solve it. So I'm going to subtract 6 to this first equation, so I got t equals negative 6, and I'm going to add 3 to this equation, so I got t equals a positive 3. And the last thing I have to do, since I have two solutions, is to check my work. So we're going to let t equal negative 6, and we're going to let t equal positive 3. I go back to my original equation, so I go negative 6 parentheses squared equals negative 3 times negative 6 plus 18. Okay, so negative 6 squared is going to be a positive 36, because negative 6 times negative 6 is a positive 36. Negative times a negative is going to be a positive, so I got positive 18 plus 18. And 36 equals 18 plus 18 will give me 36. So those two will definitely check out. I come over and I box my t equals negative 6. Now I've got to let t equal positive 3. So I go 3 squared equals negative 3 times 3 plus 18. So 3 squared will definitely give me 9. A negative times a positive is going to be a negative. 3 times 3 is 9 plus 18. Negative 9 plus 18 will give me a positive 9. 9 equals 9. That is a true story. So I come and I box my answer. I hope you did well on this. Alright, now what we're going to do is we're going to solve a quadratic equation with a common factor. Okay, so really what this means is a GCF, because we want to make the answer as simple as possible. So we got 3m squared minus 9m equals 30. First thing we got to do is we got to make sure and set it equal to 0. So I'm going to subtract 30 from both sides. So I've got 3m squared minus 9m minus 30 equals 0. So now what I see is I've got to see if I can pull out a GCF, which I have a 3, a 9, and a 30. So absolutely I can pull out a GCF, and the GCF that I can pull out is going to be a 3. So when I pull out a 3, I'm going to be left with m squared minus 3m minus 10 equals 0. Okay, so I just made it a lot easier for myself. So inside of my parentheses, I've got 3 terms. When I have 3 terms, it can either be an a equals 1, a doesn't equal 1, or it could be a perfect square trinomial. So again, this is going to be a equals 1. So when I have an a equals 1, what I want to do is I want to set up this 3 on the outside, and then I want to set up my 2 binomials. Go m, m. Because it's minus minus, that is going to be plus minus. So then I have to find the factors of 10, which are 1 and 10, and 2 and 5. There's not any others. Because my signs are different, I'm going to have to use subtraction to get to my b, which is a negative 3. So what I'm going to end up using is the 2 and the 5. Order's super important. It needs to be 2 minus 5 to get me to negative 3. So I go 2, I go 5, equals 0. Alright, so now I've got to set each factor equal to 0. So technically, I would go 3 equals 0, m plus 2 equals 0, and m minus 5 equals 0. But if I look at it right here, 3 equals 0, that's not even a true statement, and we don't have m by itself. So this part, you can write it if you want to, but it's not necessary. Because really what I care about is I want to get m equal to some type of number. So for m plus 2 equals 0, what I want to do is I want to subtract 2 on both sides. So I get m equals negative 2. I want to add 5 on both sides. So I go m equals positive 5. Okay, I've got 2 solutions. I have to check my work. So I'm going to let m equal negative 2. And I'm going to let m equal a positive 5. I go to my original equation, so I go 3 times negative 2 parentheses squared minus 9 times negative 2 equals 30. Okay, orders of operations, please excuse my dear Aunt Sally. So first thing I got to deal with is I've got to deal with this exponent. So I'd go 3 times negative 2 would be a positive 4. Okay, and then I'm just going to clean this up. Negative times a negative is a positive. 2 times 9 is going to leave me with 18 equals 30. Okay, and then 3 times 4 will give me 12. 12 plus 18 gives me 30. 12 plus 18, 30 equals 30. That is a true story. I box my answer. Alright, now we're going to let m equal 5. So when I let m equal 5 in my original equation, I'm going to go 3 times 5 to the second minus 9 times 5 equals 30. Alright, so let's clean this up. Please excuse my dear Aunt Sally. We've got to look at exponents. So 5 squared is going to be 25. So I'll go 3 times 25. Negative times positive is a negative. 4 times 5 will leave me with 45 equals 30. 3 times 25, think of quarters, so 25 cents plus 25 cents plus 25 cents will leave me with 75 cents. Minus 45 equals 30. And 75 minus 45 will give me 30 equals 30. That is a true story. I box my answer. So, is this process tedious? Absolutely. But I want you to be absolutely sure that you get this right for your test. So please, please, please take this serious while you're working through these problems. Alright, so let's try another one where we are going to have to pull out a GCF or a common factor. This one's going to take a little bit more work because it's not an a equals 1. Alright, so we got 10p squared minus 65p equals 35. First thing I got to do is I got to set it equal to 0, so I'm going to subtract 35 on both sides. So I've got 10p squared plus 65p minus 35 equals 0. So I've got 10, 65, and 35. So what I can see from here is that I'm definitely going to have a GCF, but my GCF is only going to be 5. So 10 divided by 5 is going to leave me with 2p squared. Then 65 divided by 5 is going to leave me with 13p. And 35 divided by 5 is going to leave me with 7 equals 0. So inside of my parentheses, I've got 3 terms. So when I have 3 terms, it's going to be either a equals 1, a doesn't equal 1, or a perfect square trinomial. If I look at this, I got my a does not equal 1. So this is section 6.3. So this is definitely going to take some more work. So what I'm going to do is I'm going to go through the steps up here just to kind of keep it clean. So I'm going to go 2p squared plus 13p minus 7. The 5 doesn't really matter just yet. Alright, so when I have an a does not equal 1, I have to take my a times my c. So I go 2p squared times negative 7, which 2 times 7 will give me 14, so it's going to be negative 14p squared. That's step 1. Step 2, since it's negative, we know that it's going to have to be subtraction in order to get to our b, which is 13p. Alright, so then we find the factors of 14, so 1 and 14, 2 and 7, and that's it. And in order to get to a positive 13p, I've got to use the 1 and the 14, and it's got to be 14p minus 1p. Okay? Because 14p minus 1p will get me to 13p. So now I've got to write my 4 terms, so I go 2p squared plus 14p minus 1p minus 7. Alright? So I've got 4 terms. When I have 4 terms, I put them into 2 groups, put my little plus in front of there. So if I have 2p squared minus 14p, I got to pull out a GCF, so my GCF is going to be 2p, which will leave me with p plus 7. If I look at this next equation, I've got negative 1p minus 7. Both of those are negative, so I'm going to pull out a negative 1. That's the only thing that they have in common. And I'm going to be left with p plus 7. My binomials are the same. So I'm going to come back down here. I'm going to write my 5. I'm going to put my common binomial of p plus 7. And then I'm going to write my rest of it. So it's going to be 2p minus 1 equals 0. Okay? So now what we got to do is we got to set these equations that we just factored equal to 0. So that's step 3. So p plus 7 equals 0. 2p minus 1 equals 0. And remember, you can do 5 equals 0, but that's not a true statement, so you don't have to do that if you don't want to. Alright, now we got to solve, so I'm going to subtract 7 on both sides. So I got p equals negative 7. I'm going to add 1 on both sides, so I've got 2p equals positive 1. Then I'm going to divide by 2, so I got p equals positive 1/2. So again, dealing with fractions. But that's just kind of how the story rolls. Alright, so we're going to let p equal negative 7, and we're going to let p equal 1/2. So we go to our original equation, so we go 10 times negative 7 parentheses squared plus 65 times negative 7 equals 35. Okay? So let's take it one step at a time. Hopefully you have your calculator. According to Please Excuse My Dear Aunt Sally, you got to deal with exponents first. So negative 7 times negative 7 is positive 49. Positive times a negative is going to be negative. 65 times 7 is going to be a negative 455 equals 35. Okay? So now 10 times 49, that's going to be 490 minus 455. Which equals 35, and 490 minus 455 is going to be 35. So 35 equals 35. If that's a true story, I can come and box my answer. Now if we let p equal 1/2, we're going to go 10 times 1 over 2 parentheses squared plus 65 times 1 over 2 equals 35. Alright, according to Please Excuse My Dear Aunt Sally, we have to deal with exponents first. Okay, so if I'm looking at exponents first, 1/2 squared is going to be 1/4. So I go 10 times 1/4. Okay, I'm going to put this 65 over 1. Unfortunately, there's nothing that I can cross cancel, so I'm going to multiply straight across when I have fractions. So 65 over 2 equals 35. Okay, now again, I'm going to put this over 1. I'm going to look to see if I can cross cancel. The 10 and the 4 are both even, so 2 can go in them. So 10 divided by 2 is 5. 4 divided by 2 is 2. So I'm going to be left with 5 over 2 plus 65 over 2 equals 35. And I got common denominators, so 5 plus 65 is 70 over 2 equals 35. And then 70 divided by 2 will definitely give me 35. So 35 equals 35. I box my answers. So right here, if you did this with a calculator, you would have gotten 2.5 plus 32.5 equals 35, which would have cleaned up to be 35 equals 35. I don't really care if you use a calculator or not, but I do need to make sure and see this work. This is probably about as hard as a GCF problem will get. Yeah, I would say so. But you definitely have one like this on your homework. Alright, so now we're going to look at some tricky problems. And the only reason why they're tricky problems is because you're probably just not as comfortable with some of the tricks just yet. So, I've got 9x squared minus 64 equals 0. Step 1, make sure that it's set equal to 0. Step 1's done. Step 2, we have to factor it. Okay, so if I have two terms, it could either be a GCF or it could be a difference of perfect squares. So for this one, I see that 9 and 64 are definitely perfect squares. So this is a difference of perfect squares, or of two perfect squares. Either way totally works. And it's subtraction, so we're good as gold. So what we do is we take the square root of 9x squared, which is just 3x. I take the square root of 64, which gives me 8. I set up my two binomials. I go plus, minus, and then I just go 3x plus 8, 3x minus 8. And this is what we did in 6.4. Alright, so we factored it. Now we have to set each factor equal to 0. So we go 3x plus 8 equals 0, 3x minus 8 equals 0, and now we have to solve. So minus 8, 3x equals negative 8, divide by 3, x equals negative 8 over 3. Wish that cleaned up more, but it doesn't. So I'm going to add 8 to my second equation. So I've got 3x equals 8. I'm going to divide by 3 on both sides, and I got x equals positive 8 over 3. So first one, we're going to have to let x equal negative 8 over 3. And then we're going to have to let x equal positive 8 over 3. Okay, so let's do this. We plug it into the original equation, so we got 9 times negative 8 over 3 parentheses squared minus 64 equals 0. Alright, the easiest way to deal with this is just to go like this. Apply to the numerator and the denominator, so negative 8 times negative 8 would be positive 64. And 3 times 3 will be a positive 9 minus 64 equals 0. We put this over 1 because it creates two fractions. And when we have two fractions using multiplication, we try to cross cancel. So the 9's will cross cancel, leaving me with 64 minus 64 equals 0. And 64 minus 64 is 0 equals 0, which is a true statement. So I can go and I can box this first answer. Now we're going to let x equal positive 8 over 3. So we got 9 times 8 over 3 parentheses squared minus 64 equals 0. Excuse me. Alright, so I'm going to apply my exponent to both the top and the bottom of my fraction. So I'm got 9, and then I got 64 over 9 minus 64 equals 0. I'm going to put this over 1 again, because when I put it over 1, a fraction times a fraction, I can look to cross cancel. The 9's will cross cancel with each other, and I'll be left with 64 minus 64, which is 0, so 0 equals 0, true statement. Box my answer. Alright, another tricky problem is the one that looks like this. So it's very, it might just be challenging to look at initially on how to even approach this problem. But go through your steps. So we're going to set each equation to 0. So I've got to set this equation equal to 0. So once I do that, if I've got m squared equals 5m, what I would need to do is I need to subtract the 5m on both sides. So now I've got m squared minus 5m equals 0. So now it doesn't look as intimidating. Step 2, we have to factor it. So when we factor it, we got two terms, so it either can be a GCF or it could be a difference of perfect squares, or technically it could be the sum or difference of perfect cubes, but you're not going to see that in this section. So this is actually going to be a GCF, and what we can pull out is an m. So when we pull out an m, we're left with m minus 5 equals 0. So next thing we got to do is got to set each factor equal to 0. So m equals 0, and then m minus 5 equals 0. We add 5 on both sides, so we got m equals positive 5, and we got m equals 0. Because I only have two solutions, I'm going to let m equal 0, and I'm going to let m equal positive 5. Go to my original equation, so 0 squared equals 5 times 0. 0 squared is 0. 0 times any number is 0. Bam, done with that one. I'm going to let m equal 5, so I would go 5 squared equals 5 times 5, so original equation. 5 squared is 25, and we know that 5 times 5 is 25. That's a true story. I box my answer, and I'm done with that problem. Alright, here is another tricky problem that you will see. So, I've got 2x to the third minus 50x equals 0. Step 1, we have to set each equation equal to 0. So we set that equation equal to 0. That's already done for us. Step 2 is we've got to factor it. Alright, so we have two terms. And with the two terms, what we see is we see this lovely thing of a cube. But 2 and 50 are not perfect cubes. So what this tells us is we're going to have three solutions, and we can't, and we got to use some type of GCF to pull out. So if I look at this equation, and I do first a GCF, what I can pull out is 2x. When I pull out 2x, I'm left with x squared minus 25 equals 0. Okay? Now, if I look within my parentheses, after I pull out a GCF, what I can see is I have two terms. So either GCF or difference of perfect cubes. I'm sorry, perfect squares, which 25 is definitely a perfect square, so this is a difference of perfect squares. So I set up my 2x right there. I take the square root of x squared, which is x. I take the square root of 25, which is 5. I set up my binomials. I go plus minus equals 0. So x plus 5, x minus 5 equals 0. Alright. So now what I've got to do after I factor it is I have to set each factor equal to 0. So I'm going to go 2x equals 0, x plus 5 equals 0, and x minus 5 equals 0. Again, I'm going to have three solutions because I've got x to the third power. So to solve this one, to get x by itself, I have to divide both sides by 2. So x equals 0 divided by 2 is going to be 0. X plus 5, I'm going to subtract 5 on both sides, so I get x equals negative 5. And I'm going to add 5 on both sides, and x equals positive 5. So, since I have more than two solutions, I am done right here. Alright, I've got one more problem for us to try, and this one is definitely going to take work. Alright, so we got a binomial times a trinomial. Okay, so this is kind of where they've already factored it a little bit for us, and it's going to be a difference of two perfect cubes, kind of, sort of. So, first thing I got to do is I've got to check to set the equation equal to 0. We already have that. Step 2, we have to factor it. This binomial was already factored for us, but this trinomial is not. So what we got to do is we got to factor this trinomial. So if I've got three terms, it can either be a equals 1, a doesn't equal 1, or a perfect square trinomial. So first thing I'm going to do is I'm going to look to see if I can pull out a GCF. I can't pull out a 2 because of this 5 right here. So now I'm going to look, and it's definitely going to be a does not equal 1. So that's going to take work. So I'm going to come up here and I'm going to go 2a squared minus 5a minus 12. And I'm going to go through my steps. So a times c, so 2a squared, times negative 12 equals negative 24a squared. Because it's subtraction, I've got to put a minus, and I'm trying to get to a negative 5a, so I'm trying to get to that b. Find my factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6, and that's it. Okay, so in order for me to get to a negative 5a, I've got to use this 3 and 8. Order is going to be important. So I'm going to go 3a minus 8a, and that will get me to a negative 5. So now I'm going to take this, I'm going to replace it back into my b, and I'm going to go 2a squared plus 3a minus 8a minus 12. I've got 4 terms, so I factor by grouping. What I can pull out on my first is just an a, so I'm left with 2a plus 3. What I can pull out of my second is a negative 4, and it will leave me with 2a plus 3. My binomials are the same, so I'm going to come back over here and I'm going to go 3a minus 1 times 2a plus 3, and then I'm going to write my leftovers, so I've got a minus 4. So again, I'm going to have 3 solutions because I've got 3 factored equations. Alright, so I'm going to go 3a minus 1 equals 0, 2a plus 3 equals 0, and a minus 4 equals 0. Now, because I have 3 solutions, do I have to check my work? Nope. Alright, so all I got to do is solve this and then I'll be done. So I'm going to add 1 on both sides. So I got 3a equals positive 1. I'm going to divide both sides by 3. So I got a equals 1/3. Box my answer because I'm done with that. Second equation, I'm going to subtract 3 on both sides. So I've got 2a equals negative 3. Divide by 2. And I got a equals negative 3 over 2. Box my answer. Then I'm going to add 4 on both sides, and I get a equals positive 4. So we got my 3 solutions, and I'm done. You will definitely have a homework problem like this. That's why I wanted to cover it with you. I'm pretty sure it's the last one. But please make sure you show all work. If there's only 2 solutions, you need to make sure and check your work. Next time I see you, please make sure you have questions. Alright, thank you.